All right, from page 251, 11 through 39, every other odd, number 31. The integral tangent squared y plus 1 dy. Okay, let's see. Well, first thing I notice is it's in y, but everything works the same. It's just my answer will be in y, so I don't think that's the major concern here. The other concern is tangent squared, and I'm thinking through my trig functions, and I know sine goes to cosine, and cosine goes to negative sine, so it's not that. Tangent goes to secant squared, and that means cotangent goes to negative cosecant squared, so that's not it. Secant goes to secant tangent, which means cosecant goes to cosecant cotangent with a negative. So it's not any of those. And I guess that's like, well, what is this then? But that plus 1 on there makes me think that this could be a trig identity. Right? Sine squared plus cosine squared is 1. That's not what this is. But if I get creative and I divide everybody by cosine squared, you might remember that's how we get the other of those Pythagorean identities, either divide by sine squared or divide by cosine squared. Now we have tangent squared plus 1 equals secant squared. Oh, that's what we want. So this called upon a trig identity that we probably haven't seen in a long time. And even though we're kind of familiar, hopefully, with sine squared plus cosine squared is 1, the other one is a little more obscure. But whatever. We had to do some trig first here. Secant squared y. Excuse me. dy. And then now that fits. We're like, okay, that one we know. If we go backwards from secant squared, we get tangent. Tangent of y, because we're in the y variable, and then don't forget the plus c. So that was a really good question, because that one was a little bit tricky, because how do we do tangent squared? We don't, but tangent squared plus 1 we can rearrange and fix and turn it into something else. AP test, you usually don't have to know very many of the trig identities. If you remember from trig, there's a bunch, and some of them are kind of crazy. But this one, you need to know, and then you can get the other ones when you need them. Macy?
Sorry. I was just going to ask for another question.
Okay. Anything else on this one?
39.
39. So the second derivative is 2. The first derivative at 2 is 5. And the function at 2 is 10. So this is one of those differentiable equations where we've got the answer. We need to back up twice and use our initial conditions to figure out the c's. Let me read the directions and make sure I'm doing the right thing here. Find the particular solution that satisfies the differential equation and the initial condition. All right, so let's back up one step. The second derivative is 2. We back up from that. That would be 2x plus c. So there's our first antiderivative. And we can use that information. So f prime at 2 would be 2 times 2 plus c, and it equals 5. So c equals 1. So our first derivative then is 2x plus 1. Good so far? We need to back up one more step to get back to f. So f of x, if I antiderivative 2x would be x squared, antiderivative 1 we get x, and then we got to remember to put a c on there. Again, we've already solved for c, and kind of c is gone from the equation, so we want to use c again, we can. If that's bugging you and you want to call it c2 because it's a different c, That's fine, as long as you know that it's a different c. And then now we can use f of 2. F of 2 would be 2 squared plus 2 plus c2 equals 10. So 4 plus 2 is 6. So c2 is 4. And so now we've got everything we need. F of x equals x squared plus x plus 4. And I guess if we really wanted to make sure, we could plug this in again. If we plug in 2, 4 plus 2 plus 4 is 10. That works. If we take a derivative, we get 2x plus 1. Plug in 2, we get 4 plus 1 is 5. And if we took a second derivative, we'd get 2, which is what we started this problem with. So we don't have to do that, but it's not a bad check, and it's usually a quick check to see if it works. Other questions from 251? Okay, I'm glad you asked both of those. The trig thing is important. And for whatever reason, the differential equation is one that's frequently missed on the test. I think there's only one of them, and it's not a difficult one, but maybe now that you've asked it, we won't miss it this year. Find out later.